Hi, let's look at this lesson from Envision lesson 5.5, and this is on solving inequalities with multiplication and division, and we're also going to graph them. I'm going to see here in the same way is true for a lot of things. Add and subtract work one way, but multiply and divide there can be a little trickier, and so we can be deceived if we think we can just do the same thing we were doing, adding and subtracting, and not really paying attention to our graph. So you're going to see very quickly that when we're multiplying and dividing in an inequality, we have to make sure we check our graph. Okay, so we're going to actually start on page 279 and do the solve and discuss it first. So Alex and Hope are trying to solve this inequality. Negative 6x is greater than 24. And so Alex's work is x is greater than negative 4, and Hope's work is x is less than negative 4. But they're not really showing us their work. They're just showing us their solution. So what is this problem about? Like, what are we supposed to do about this? Well, do you notice that both of them are solving the same thing, but they don't have the same solution? They actually have opposite solutions. The one person, Alex, thinks that all the numbers that are greater than negative 4 are the right answer, and Hope thinks all the numbers that are less than negative 4 are the right answer. So those are opposites. The one thing they agree on is x can't equal negative 4. So why? Well, where did the negative 4 come from? So let's start there and see how they would have gotten negative 4. And if I imagine that this, just for a moment, I'm going to imagine that this inequality here was an equation. I'm just going to imagine it's an equation. I'm going to say negative 6x is equal to 24. So let's pretend that was an equal to sign. Then to solve this equation, I would do the opposite of multiply as divide, and I divide by the number that I'm multiplying by. So I divide by the number in front of the letter. I divide by the coefficient. So I would divide by negative 6. So x equals negative 4. So if this was an equation, then x would equal negative 4. But it doesn't equal negative 4, because for both of them, he thinks it's greater than negative 4 and she thinks it's less than negative 4. Either way, it doesn't equal negative 4. Okay? Because if we were on this number line and negative 4 would be here, then we would have, what they're saying is it would be an open circle. Let's see why. Let me put my solution back in my inequality. Negative 6 times negative 4, is that greater than 24? Well, when I do negative 6 times negative 4, I get the answer to be 24. Well, 24 is not equal to 24. So we noticed when we solve these, when we do our check, and we get this, where the number on both sides is the same number, but it's not a true statement, then that means it's an open circle. It means I probably have I have the correct target number. Negative 4 is the correct target number, but it's not a closed circle, it's an open circle. The part they disagree on is whether you should shade to the right, which would be greater than negative 4, or whether you should shade to the left, which would be less than negative 4. They both agree that there would be an open circle at negative 4, and so do we. We don't believe that that solution would work. So which one is it? I'm going to clear all my writing here. So who do we agree with? I want you to pause. Well, first, think about that. Pause the video and make a decision about who do you think has the correct solution and why. Okay, so what I'm going to do, now that you're back, is I'm going to go back to that number line that I had. And we already agreed that negative 4 is the target number. And it's an open circle at negative 4. So over here, to the left of negative 4, are things like negative 5, negative 6, negative 7, negative 8. And to the right of negative 4 are negative 3, negative 2, negative 1, 0. So if Alex's work is correct, let me put that in blue. If Alex is correct, okay, then the numbers that are greater than -4 would be over here. Then this would be the way we would graph it. This would be the solution. If Hope is correct, then all the things that are less than -4 going in this direction would be the solution. That's why I put it in green. So to figure out who's correct, I'm just going to check both of them and see which one solutions work. So I'm going to pick a number for Alex. I'm going to pick a number that is greater than -4. So over here in his blue arrow. So something like -2. And I'm going to put it in the inequality. So -6 times -2, is that greater than 24? -6 times -2 is 12. Is 12 greater than 24? No, it's not. Why are you looking at me? Of course it's not. No, 12 isn't greater than 24. So that means that Alex has the wrong solution. He would be graphing in the wrong direction. So it's not this way. So let me see if Hope is right. Maybe we're just hopeless. Ha 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 ha. Just kidding. So let's check Hope. So -6 times x is greater than 24. That's true. But let's see if we choose one of the solutions over here, like -6. So is -6 times -6. Now, the second -6 I said, that's what I'm plugging in for x. So -6 was already in the inequality, and then I'm substituting -6 in for x. Maybe I should have used a -8, not to confuse you. But are these things greater than 24? I'm just doing my substitution step. So now I do -6 times -6 is 36. Is the number 36 greater than 24? Yeah, it is. Yeah, of course. So that means Hope is correct. Ding, ding. How many of you picked Hope? Yay. So Hope has the correct solution. And we know that from the graph because here are the different things. And I could use something else from this side, like -10. So -6 times -10 is 60. Because a negative times a negative is a positive. It'd be positive 60, and that is greater than 24. So if you're thinking about this, well, how did Alex get it wrong? Why did he pick the wrong solution? If we go back and when we solved it, remember when we solved it, we treated it like an equation? Well, what if I just left it as an inequality? And I solved by division. And I just said, well, solve, divide by -6, divide by -6. And I would think x, and I would get -4. And normally we just bring this symbol straight down, and we would think that x is greater than -4. And we would agree with Alex. Well, we've already checked it, and we know that's not true. That x is not greater than -4. The numbers that are greater than -4 are like 7. Like 7 is greater than -4. If I put 7 in here, -6 times 7 will be a -42. That's not greater than 24. So by leaving it this way, I would have the wrong solution. I would actually be graphing it in the opposite order. So that's not going to do. We're not going to be able to just, like before, just assume to bring this down. We're going to have to check it. And that's what we're going to see. And maybe over time, you'll see when you have to check it and when you don't. But that's where we're at today. So the actual solution is flipped. X is less than -4. Let's look at another example. So here's just an example from it's not from the book or anything. It's just like a generic example. It says 4 times n is greater than 8. So 4 times n is greater than 8 is an inequality. And normally we would just solve an inequality like an equation. So I'm going to do that, and I'm going to divide both sides by 4, because that's the opposite of multiplication. So I'm going to get n is possibly greater than 2. But we learned last time that we don't just want to assume that that's the correct solution. We're going to want to check it. And first we want to check it, to see if we solve correctly. So we're going to RSS. This is just to check to see if we have the right target number. So 4n is greater than 8. 4 times 2, is that greater than 8? Well, 4 times 2 is 8, and 8 is not greater than 8, but these two things are the same number. So that tells me I have the correct target number, but since this is not a true statement, it's going to be an open circle at 2, because 2 is my target number. Open circle at 2. And that makes sense because there's no line there. Now, I need to check and see which way to graph. So, I'm going to start with what I think it is. I think it's greater than 2, okay? So I think it's greater than 2, so I'm going to pick something greater than 2. I'm going to choose 5. And now I'm going to check it. So 4n is greater than 8. 4 times 5 is greater than 8. 4 times 5 is 20. Is 20 greater than 8? Yes. That means 5 should be a solution. So if 5 is a solution, I could just mentally check 4 times 4 is 16. That's greater than 8. 4 times 3 is 12. That's greater than 8. So yeah, these things over here are the solution. And just to prove it, I'm going to pick something over here, like 0, and see, is 0 a solution? Because 0 is on the other side of 2. 0 is also a solution, then I might have a problem. So 4n is greater than 8. What happens when I do 4 times 0? Is that greater than 8? Eesh. Well, 4 times 0 is 0. I can't write it. Is 0 greater than 8? No, 0 is not greater than 8. So 0 is not greater than 8. That's not true. So that means over here are not solutions. Like 1 times 4 is 4, not greater than 8. Negative 1 times 4 is negative 4. That's not greater than 8. So these over here are not greater than 8. So that's why the solution goes that way. So it appears that when we solved it, just like a regular equation this time and divided, we actually end up with the correct solution, even though last time we didn't. So how are we going to know? Well, eventually you might know. But until then, I would just keep checking. So here's one where the number is on the other side of the inequality symbol. And this can be tricky. This says 14 is greater than 3.5 times c. So I always read from left to right. If I was going to read from right to left, notice how the symbol that's pointing towards the variable is the pointy end, which is the smaller end. So if I was going to read it backwards, it would look like the opposite. I'm not going to read it though because I don't want to confuse you. So we're going to solve this as if it was an equation and then see what happens. Whoops, not this one. We're not on this one yet. We're still on this one back here. That's it. Yes. Okay. So to solve this, the opposite of multiply is divide, and I'm not going to divide by 14. I'm going to divide by the number in front of the letter. That's 3.5. So I'm going to divide both sides by 3.5. And when I do, 14 divided by 3.5 is 4. I'm going to use this symbol for now, and I'm going to have c over here. So I have 4 is greater than c. And then I'm going to check, make sure that I have the correct solution, or the correct target number, which is 4. And I get 14. First I just write this. I'm sorry, I don't get anything. But when I do my substitution, make sure to copy everything as it was. And I get 14 is greater than 14. Well, 14 is not greater than 14. That's not true, but these are the same number. So since it's the same number, it means I have the correct target number. But they're not a true statement, so it's an open circle. This is like the limit. So there's my open circle at 4. Because that's my target number. So that's what we're solving. Now, which way do we graph? Well, I think because there's a greater than symbol, I think I'm going to graph on this way because I see this symbol. So I'm going to check a number greater than 5. So greater than 4. I'm going to check 5. And I'm going to put it in the inequality. So I'm going to write 14 is greater than 3.5 times C. And C here is, I'm running out of room, so C here is 5. So I'm replacing the C with a 5. I apologize for skipping a step. I was just running out of room. So when I do that, I get 14. It's still 14, still using the greater than symbol. And then 3.5 times 5 is 17.5. Is this a true statement? Is the alligator eating the bigger number? No. It says 14 is greater than 17.5. That's not true. This is false. So 5 is not part of my solution. I shouldn't be graphing over here, even though I have this greater than symbol. Well, maybe I should be graphing over here. So I'm going to choose a number that's less than 4. I'm going to choose like 2. I'll pick 2 and see if that works. So 14, I didn't erase anything over here. I left that. That's not a mistake. That's just my work. So it's okay that it's over there. So 14 is greater than 3.5 times C, and you would rewrite that, and then you would substitute in 2 for C, and I would get 14, still there, still greater than, and 3.5 times 2 is 7. Is this a true statement? Is the number 14 greater than 7? Is the alligator eating the bigger number? Yes, this is true. So that tells me that the solutions are actually on this side of the 4, all the things that are over here. Well, all the things that are over here, see the symbol here? All the things that are over here on this side are C is less than 4. It's the less than symbol, right? 1 is less than 4, 2 is less than 4, 3 is less than 4. So C is actually less than 4, not greater than 4. So that's my correct solution. So I check my graph, that helped me check my solution. If I look back up here, I realize, see how the pointy end is pointing towards the C? And then if I change the order, I have to change it so that the pointy end is still pointing towards the C. So these actually say the same thing. If 4 is greater than C, then C is less than 4. So that's my solution, and there's my graph. So let's try another one. And again, I'm just going to solve it like it's an equation, even though that didn't work the last time or the first time, but we'll do it anyway. So the opposite of multiply is divide. So I'm going to divide both sides by -5. And I get m. And 15 divided by -5 is -3. So m would be less than -3. And then I'm going to check it. So RSS. And I'm going to check my target number. The target number here is -3. So I would do -5. M is less than 15. That's true. Well, if I make -5 times -3, is that less than 15? Well, a negative times a negative is a positive, and 5 times 3 is 15. So this is actually positive 15. Now, positive 15 is not less than 15, but I have the same number on both sides. That tells me I have the correct target number, but it's just an open circle. So I'm going to put an open circle at the -3, my target number. Now, if I look at my solution here, it looks like m is less than -3. It looks like I should be graphing on the less than side. So I'm going to pick something less than -3, like -5, because that's easy. And I'm going to check it. So -5 times m is less than 15. That's true. So what happens when I substitute in a -5 for m? Do I still get a true statement? It's -5 times -5. Did it again. This first -5 is from the inequality. The second -5 is that I chose -5 here. Is that less than 15? Well, a negative times a negative is a positive. This would be positive 25. Is 25 less than 15? No, of course not. No. So this isn't right. I shouldn't be graphing this way. I shouldn't be graphing to the left of -3. Let me try something on the right of -3, like something easy, like 0. -5m is less than 15. So -5 times 0. Is that less than 15? Yeah, because 0, -5 times 0 is 0, and 0 is less than 15. So it looks like the 0 works. So that means the things on the right here are actually the solution. So those are the things that are less than -3. All the things over here are greater than -3. So I need to change this inequality because the actual solution is m is greater than -3. See how now my inequality here matches the arrow? It's going this way. So it looks like it flipped. It's like the opposite of what I thought it was. It's actually greater than -3. So if you noticed, the very first one and the very last one we just did, both of those when we divided, the number we divided by was a negative. So you have to be careful when dividing by a negative. So this is an example on page 280 from your book. Gina's pet, pot-bellied pig, is on a diet. He can have no more than 18 ounces of pig food per day. How many scoops of pig food can Gina feed the pig without going over 18 ounces? Well, each scoop is 4 ounces. So they want to know, so 4 ounces per scoop. Then if it was like 2 scoops, that would be 8 ounces. And 3 scoops would be 4 times 3 is 12. So you're going to multiply the ounces per scoop, the unit rate, times the number of scoops. That's what they did here. And the most it can be is 18. That means that the 4 ounces per scoop for the number of scoops has to be less than 18 ounces. Okay, good. So we're trying to figure out what's the number of scoops that he can have that would fit the requirement so that he wouldn't have more than 18 ounces per day. So they solved the inequality, and they solved it by dividing. See how they divided both sides by 4? Because they're multiplying the number of scoops times 4. And when they did, they have S is less than or equal to 4.5. Well, we should check and make sure they graph the right way. So I'm going to pick a number over here that is less than 4.5, like 4. I mean, they're pretty close, right? So let's see. What if I did 4? I did it again. 4 times, now I'm replacing the S with 4. 4 times 4, is that less than 18? Yeah, it is. So that means that this is actually being graphed in the correct direction. So example 2 in your book, after the try it, has another example where you have to divide to solve because it's -3.4m is less than or equal to 17. And so they divide both sides, but look what happens. When they divide both sides, they switched the inequality around. Normally we just bring it down. They switched the inequality. And they graphed to the right here. They graphed things that are greater than -5. Well, let's just check their solution and see if they did it right. So I'm going to pick a number that's greater than -5. I'm going to pick -2. Okay, so well, 3.2. A negative times a negative is a positive. And if I multiply 3.4 times 2, I get 6.8. But it's positive 6.8 because a negative times a negative is a positive. Is that less than 17? Yes. So it looks like this blue bar is actually showing the correct solution. It's colored in because m can also equal -5. So they flip this symbol around from here to here. Notice how it flips around. It was going one way, now it's going the other. And by doing that, by flipping it, they get the right solution. Well, why? Why did they flip it? Like, what made them flip it this time and not other times? And the difference is they divided by a negative. So think about those examples we had. Anytime we divided by a negative, that's when our solutions actually flipped around. Here's our last example that we'll go over, just in case you thought it was only when you divide by a negative. But in this case, to solve this problem, you need to do the opposite division, you need to multiply. And so we're going to multiply by the number that's under the variable, the one that's being divided. So I'm going to multiply both sides by negative 2.5. That'll cancel out the negative 2.5 on the left. And then 7 times negative 2.5. 7 times negative 2.5 is negative 15.75. But notice how this inequality used to be a greater than symbol and now it's flipped around. Well, why? Let's try something that actually is greater than. Okay, so here's negative 9. So let me try negative 9. It's not shaded, so it's not supposed to be part of the solution, but I'm confused because I feel like it should be greater than symbol. So I'm picking something greater than negative 15.75, like negative 9. So I'm going to do negative 9 divided by negative 2.25. Well, what would that equal? Well, it's going to equal positive 4 because positive 4, so a negative divided by a negative is positive. So this would be positive 4. Is positive 4 greater than or equal to 7? No. So if I left the symbol the same as it was before I multiplied by a negative number, then I would have thought the solution was greater than. But it turns out, because we multiply by a negative number, it actually flips. So if I try something like I get the number as 8. Okay, so going back to the beginning, remember it was r divided by negative 2.25 is greater than 7. And if I divide these things, a negative divided by a negative is a positive. So the number I get is 8. And is 8 greater than or equal to 7? Well, yeah, it's greater than 7. That means that this is the side with my solutions. So this is graphed correctly, and this is the correct solution. So it actually flipped. Well, why? Because we multiplied by a negative. And you can pause and solve that now. Then if I have, welcome back, I have k divided by negative 0.5 less than 12. If you haven't already paused and to try this yourself, you can pause now and try it and then come back. But if I'm going to solve this, the opposite of division is multiplication. So I'm going to have to multiply both sides by negative 0.5. And I'm multiplying by negative 0.5. So I would have k over here. If I just bring the symbol down, I have this. And negative 12 times negative 0.5 is negative 6. Okay. So, and I would think k is less than negative 6. So that's my target number. And I would check it. I would put negative 6 in my inequality and see if that works. So I put 12 here. So I just wrote the exact thing it was from before, except with negative 6. Negative 6 divided by negative 0.5. Well, a negative divided by a negative is a positive. And 6 divided by 0.5 is 12. 12 is less than 12. Well, 12 is not less than 12, so I should have an open circle here, but I should have the correct target number. So I'm going to put negative 6 right here in the center and give it an open circle. An open circle at negative 6. So I'm going to make, 5, 4, 3, 2. Here's negative 2 over here. And 7, 8, 9, 10. Here's negative 10 over here, which makes this over here 0, by the way. So if I go with my solution the way it is, it looks like I'm supposed to be graphing this way. So I'm going to pick like negative 10 here and put it in my inequality. So negative 10 divided by negative 0.5. Well, is that less than 12? A negative divided by a negative is positive, and negative 10 divided by So 10 divided by 0.5 is 20. Is 20 less than 12? No, 20 is not less than 12. So this is not the direction I should be shading. I need to check. Then I need to check this side. So -2 divided by -0.5. Well, a negative divided by a negative is a positive, and 2 divided by 0.5 is 4. Is 4 less than 12? Why, yes, it is. So that means my solution is going this way. Here are the things that where my solution is on this side. Well, these things here aren't less than -6. These things on the right are greater than -6. All these numbers are greater than -6. So my solution is really k is greater than -6. So why did it switch sides? Because of the negative. Is it always going to switch sides? No. Only when I multiply or divide by a negative. But there you go. So there's your lesson on multiplication, division. I just heavy on checking. If you check, you're going to get the right answer. So I just encourage that. Thanks for watching.